This is day 4 of Unit 3, Section 2. So for our first examples, we're going to factor the left side, and then we're actually going to solve by square roots, and you'll see what I mean. So if I wanted to factor x squared minus 10x plus 25, I'm ignoring the fact that this side's 81. I'm looking for what multiplies to 25 and adds to negative 10. So looking at positive 25, right, adding to a negative, so it has to be negative and negative. So we have negative 1 and negative 25, 2 no, 3 no, 4 no, negative 5 and negative 5. And negative 5 and negative 5 do in fact add to negative 10. So this is really x minus 5 times x minus 5, or, because it's twice, x minus 5 squared. And now we can solve by square roots because I have something being squared. So if I were to take the square root of both sides, the square root of x minus 5 squared is really x minus 5, and we get plus or minus the square root of 81 I could actually take is 9. So now if I were to add 5 to this side, we get 5 plus or minus 9. Now normally, if one of these was a square root or imaginary, I would leave it like that, but this can actually be done. We have 5 plus 9, and we have 5 minus 9. So x would equal a 14, or x equals negative 4. All right, let's do the same thing for b. I'm looking for what multiplies to positive 16 and adds to positive 8. All right, 1 and 16, 2 and 8, 4 and 4, and 4 and 4 are the magic numbers. So this is going to be x plus 4 times x plus 4, or x plus 4 squared. So from here, take the square root of both sides. So we're left with x plus 4 equals plus or minus. We can take the square root of 100 and we get 10. And we remember that the square root of a negative is I. So now if I subtract 4 from both sides, standard form means I'm going to put the negative 4 in front and the plus or minus 10i in the back. And that's our answer. All right, you try these next two. Just know every time we do this, the two numbers we get should be the same because we want to end up with something squared. So for 25, it was 5 and 5 because the square root of 25 is 5. For 16, it was 4 and 4 because the square root of 16 is 4. So keep that in mind as you try the next two. Pause it and you can check your answers. So let's check these. For number 1, the two numbers that multiplied to positive 64 and added to positive 16 were 8 and 8. So we had x plus 8 squared equals 4. Take the square root, get plus or minus 2. So negative 8 plus or minus 2 gives us negative 6 and negative 10. For number 2, the two numbers that multiplied to positive 4 and added to negative 4 were negative 2 and negative 2. So that's x minus 2 squared equals negative 49. Take the square root of both sides. We get plus or minus 7i. And then I add the 2. So we get 2 plus or minus 7i. This process is actually called completing the square. So we are always looking for what the c value will be that would allow us to complete the square, to factor it so that it turns into something squared. So in order to find that c value, we're going to take the b value and cut it in half and then square it. So we're going to look for the value of c, and then we're going to rewrite it as the factored form. So I'm going to take the b value, I'm going to cut it in half, and then I'm going to square it. So 6 squared is 36, so c would be 36, which means this would really be written as x squared plus 12x plus 36, and I know that this can be factored to x plus 6 squared. The same 6 I got here is the 6 that went here. If we look at b, take the b value and cut it in half, and then we square it. So c in this case would be 81. So if x squared minus 18x plus 81 is our expression, our factored form right? X minus 9. So you try the next two, pause it, and then you can check your answers. Let's check these. Half of negative 24 is negative 12, and squaring that I get 144. So that would be the C value. And then the two numbers that multiplied to 144 and added to negative 24 were negative 12 and negative 12. For number 4, half of 14 is 7, squared is 49, so C is 49. And the two numbers that multiply to 49 and add to 14 are positive 7 and positive 7. If we want to solve by completing the square, we're first going to get the left side of the equation to have only variables. So the x squared and the bx. We're going to move c to the other side. So to complete the square, we're going to find the new c value, right? The same kind we just did in these two problems. We find the new c value. But we're going to add it to both sides of the equation, right? If I'm going to balance an equation, what I do to one side, I have to do to the other. We can factor the left side now into that binomial squared and solve by finding the square root. So in part A, I want to get the x squared and the 6x alone, so I'm going to move the positive 3 over by subtracting 3. So I have x squared plus 6x, I'm going to leave a little room for that new c value, equals negative 3, and some more room for that new c value, right? Plus and plus. So we're going to take the 6, the b value, and cut it in half, and then we're going to square it. So the c value is 9, so that means on this side I get a 9, and on that side I get a 9, right? What I do to one, I have to do to the other. So now x squared plus 6x plus 9 I can factor, right? That's x plus 3 squared. And on the other side, negative 3 plus 9, I have 6. So now I could solve this by square roots. So if I take the square root of both sides, x plus 3 equals plus or minus square root of 6. Can't be done anything there, right? 6 is not a perfect square. And then I can subtract 3 from both sides. And that's my answer. Let's do the same thing in B. I'm first going to subtract 5 from both sides. So we have x squared minus 20x plus something we don't know equals negative 125 plus something we don't know. So we take the b term and cut it in half, and then we square it. So that means we're going to add 100 to both sides of the equation. So the left side can be factored to become x minus 10 squared, and the right side, negative 125 plus 100, is negative 25. So if I take the square root of both sides, x minus 10 equals plus or minus square root of negative 25 is 5i, and then we'll add the 10. Right? Not like terms, so I can't do anything with it. And that's my answer. So you can go ahead and try these two, pause it, and then you can check your answers. All right, so let's check these. Half of 4 is 2, and 2 squared is 4, so that's what we add to both sides. So x plus 2 squared is 16. X plus 2 equals plus or minus 4 when I took the square root of both sides. And that got me to x equaled positive 2 or negative 6. For 6, half of negative 22 is negative 11, and negative 11 squared is 121. So we add that to both sides. So x minus 11 squared equals negative 9, right? Negative 130 plus 121 is negative 9. Take the square root of both sides. X minus 11 is plus or minus 3i. And when I add 11, it just becomes 11 plus or minus 3i. The last kind we're going to look at is if there was a number in front of the x squared. So normally we would say no, we're not going to do it. We're not going to complete the square if there's a number in front of the x squared. But if I can divide it out evenly and it comes to a number that is just 1 in front of the x squared, then I can do it. So here, all of these are divisible by 3. And because we're just dividing, 0 divided by 3 is still 0, we get x squared plus 4x minus 5 equals 0. So now I can complete the square by adding that 5 All right, leave a spot for what we don't know. So we cut that 4 in half, and then we square it, and we get 4. So x squared plus 4x plus 4 is really x plus 2 squared, and 5 plus 4 is 9. So take the square to both sides. We get plus or minus 3. So subtract 2. We have negative 2 plus 3, and negative 2 minus 3. So x would equal 1 or negative 5. You're going to try the last two, divide out your GCF first, and then solve by completing the square. Pause it, and then you can check your answers. All right, so the first one, we divide everything by 4. We're left with x squared plus 8x plus 17 is 0. Moving the 17 over, and then we find half of 8 is 4, square that is 16, so add 16 to both sides. So then we're left with x plus 4 squared equals negative 1. So taking the square root, x plus 4 is positive or negative I, or 1i. So if we subtract 4, we get x is negative 4 plus or minus I, or 1i. For number 3, I would divide everything by negative 3, so I'm left with x squared plus 6x plus 2 equals 0. Subtract the 2 from both sides. And then when I cut 6 in half and square it, half of 6 is 3, and 3 squared is 9. So now I end up with x plus 3 squared equals 7. Take the square to both sides. X plus 3 is plus or minus square root of 7. And subtract 3 from both sides to get x equals negative 3 plus or minus the square root of 7. And that is day 4 of Unit 3, Section 2.